Hi guys, welcome back to today's Vidyanaka online science class. We are about to continue our 12th chapter, electricity. And in today's class, we are going to discuss about resistance of a system of resistors and disadvantages of series connection over parallel connection. So what are the points we are going to discuss in our today's class? Resistance of a system of resistors and disadvantages of series connection over parallel connection. Shall we move to our today's class? Yes. As you know, resistance is the property of a material to resist the flow of charges. Resistance is the property of a material to resist the flow of charges. Before stepping into our today's main discussion, you have to know the main difference between a resistor and a resistance. What is a resistor and what is a resistance? Resistor is a material or an object shows some resistance of desired value. Resistor is an object or a material having some resistance. But resistance is the property of a material to resist the flow of charges. Which means resistor is an object. Like, nichrome wire, copper wire, etc. They are an object having some resistance. Right. So, resistor is an object or a material having some resistance or showing some resistance of desired value, and resistance is the property of that material to resist the flow of charges. So, resistors are a material having some resistance, and resistance is a property of a material to resist the flow of charges, which means resistors are objects of objects having some resistance or a materials, but resistance is the property of a material which resists the flow of charges. Okay, and next we are going to check how we can connect these resistors. What are the ways to connect the resistors? We have two connections like series connection and parallel connection, which means we can connect the resistors in series and in parallel. So which are the two ways of connection? Resistors are connected in series and resistors are connected in parallel. So we can connect the resistors in two ways like series connection and parallel connection. So we are going to discuss about resistors in series and resistors in parallel in detail. Okay, first one, resistors in series. Okay, what is a series connection? If resistors are said to be in series, if they are joined end to end. See, this is the series arrangement. Here you can see, three resistors, R1, R2 and R3 are the resistors connected in series. So these are resistors, okay, resistors. Resistors are the materials having some resistance, right? So here how many resistors are connected? Three resistors, R1, R2 and R3 connected in series. Why? Because these resistors are connected or these resistors are joined end to end. So here you can see one end, then another end is connected here and another end is connected here, then another one here. So if the resistors are joined end to end, such type of connection is said to be series connection. So if the resistors are connected end to end, such type of connection is series arrangement. So if see here see, I showed only 3 resistors. You know, we can connect many resistors, right? You know, 10, 14, 15 resistors we can connect it in series, right? So, if n resistors means, you know, many resistors, right? So, if n resistors are connected in series, or if n resistors are said to be connected in series, if these are joined end to end. If n resistors are said to be in connect or is said to be in series, if they are joined end to end. Okay, so if these resistors are connected, if the resistors are connected end to end, one end is connected to other end and other end is connected to other end, it goes like. So if the resistors connected end to end, such type of arrangement is known as series arrangement. And another very important point in series connection, and this will be help you to derive the equation for series connection, which means here in series connection we have to connect different gadgets or different resistors one by one or end to end, which means I say, right, if here all the resistors are connected in a straight way, like, you know, one end to other end likewise, right, which means in series connection I is same for all the resistors. If there are 15 resistors connected in series, these 15 resistors have same current. So the very important point related to the series connection is that I same for all the resistors in the circuit. So in series connection, which is same? I same. I is common or I is same in series connection, which means here the resistors are connected one after one, right? So when we supply electricity or when we supply current to the circuit, that current equally distributed to all the resistors in the circuit, which means I same for all the resistors. And if I is same, another point you have to keep it in your mind, potential difference is different. So in series connection, I is common or I is same for all the resistors and the potential difference is different. So what is different in series connection? Potential difference is different in series connection and I is same in series connection. So what is a series arrangement? If n resistors or many resistors are said to be in series connection if they are joined end to end. End to end arrangement is series connection, and in series connection all the resistors use same current, which means I is same for series connection and the different and potential difference is different. Keep it in your mind. These 2 points will help you to derive the series equations for the series connection. I is same and potential difference is different, and series arrangement is the arrangement in which resistors are connected end to end and I is same and the potential difference is different. Next one, resistors connected in parallel. You can see on the board 3 resistors R1, R2 and R3 connected in parallel. So this is the arrangement of parallel connection. Here the 3 resistors are connected in parallel. R1 is parallel to R2, R2 is parallel to R3. So 3 resistors R1, R2 and R3 is connected in parallel. Then what is then parallel arrangement? If n resistors are said to be connected in parallel if one end of the resistor is connected to one point, other end of the resistor is connected to other point. So if the n resistors are connected in parallel, if one end of the resistor is connected to one point and other end of the resistor is connected to other point. You can see in three resistors also their one end is connected to one point and other end is connected to another point. So if one end of the resistor is connected to one point and other end of the resistor is connected to another point, so that the potential difference across each resistor is same or equal. If the resistors connected in parallel, if it is said to be in parallel, which means one end of the resistor is connected to one point and other end is connected to another point, so that the potential difference across each resistor is same or equal across the potential difference between the points. If n resistors are said to be in connected parallel, if one end of the resistor is connected to one point and another end is connected to another point, so that the potential difference across each resistor is same and equal to the applied potential difference between the points. So one end of the resistor is connected to one point and another end of the resistor is connected to another point. You can see these three resistors, one end is connected to one point and another end is connected to another point, so that the potential difference across each resistor is same and equal to the applied potential difference. So why these points are connected to parallel? Because if we connected these resistors in parallel only, we get an equal potential difference. So if one end of the resistor is connected to one side and another end is connected to another point, so that the potential difference across each resistor is same and equal to the applied potential difference. That means R1 is parallel to R2, R2 is parallel to R3. These three are connected in parallel and the potential difference across each resistor is same. So what is same in parallel connection? Potential difference and I is different. If potential difference is same, which means I is different. So what is same in series connection? In series connection, I same, V different. But in parallel connection, V same, I different. V same, I different. So if n resistors are connected in parallel, if one end of the resistor is connected to one point, another end is connected to another point, so that the potential difference across each resistor is same and equal to the applied potential difference, which means potential difference same across each resistor and I is different for each resistors. Okay, so V is same for each resistors and I is different for different resistors. Okay, so V same, I different. Let's start our derivation. First we are going to derive the equation for series connection. Look at the board, you can see three resistors R1, R2 and R3 connected in series. Why they are connected in series? Because they connected end to end. So R1, R2, R3 are the resistances or the resistors connected in series. R1, R2 and R3 connected in series. And V1 is the potential difference across the resistor R1, V2 is the potential difference across the resistor R2 and V3 is the potential difference across the resistor R3. So R1, R2 and R3 are the resistors connected in series. V1 is the potential difference across the resistor R1, V2 is the potential difference across the resistor R2 and V3 is the potential difference across the resistor R3 and V is the potential difference across A and B or total potential difference. V is the total potential difference and I is the current flows through the resistors. Tell me guys, is we need to write I1, I2 and I3 in this derivation? Is we need to write like I1, I2 and I3? Definitely not. Why? Because I is same in series connection. What is same in series connection? I is same in series connection and V is different, right? Potential difference is different across the resistors and I is same for all the resistors, which means you have to use only I. You don't want to use I1, I2 and I3. Only you have to use I. Why? Because I is same for all the resistors. Okay, and another point, you see, I told you V1, V2 and V3 are the potential differences. V1 is the potential difference across the resistor R1, V2 is the potential difference across the resistor R2 and V3 is the potential difference across the resistor RV. Okay, so it is clear that V equal to V1 plus V2 plus V3, which means total potential difference is the sum of individual potential difference. So here V equal to, here in series connection, potential difference is different for different resistors and their sum is equal to V. V is the total potential difference across A, B and V1, V2 and V3 are the individual potential difference. So it is observed from the experiment V equal to V1 plus V2 plus V3. If we prove this V equal to V1 plus V2 plus V3 only, we can make or we can derive the equation for series connection. For that we have to assume that, or we have to prove that V equal to V1 plus V2 plus V3, which means total potential difference is the sum of individual potential differences. V equal to V1 plus V2 plus V3. Okay, next we can use the Ohm's law equation for V. What is the Ohm's law equation for V? V equal to I into R. So this is the Ohm's law equation for potential difference. V equal to IR. Then next step, you have to make equation for V1, V2 and V3. What is the equation for V1? I1 into R1. Is it correct? I1 into R1? No, it's wrong because I say. So you don't want to use I1. So simply you can write IR1 and V2 equal to IR2 and V3 equal to IR3. So these are the equations, Ohm's law equations for V1, V2 and V3. And applying this equation, what is V? V equal to IR. So IR equal to V1 IR1, V2 IR2, V3 IR3. Okay, so here also you can see I and here also you can see I. So you can take, I is common for all the resistors, right? So you can take the I out. So IR equal to, I is common, right? Then I into, so balance R1 and here R2 and R3. See, IR1, IR2, IR3. So we took the I outside. So if we took the I outside, what remains? R1, R2 and R3. Okay, and next step, cancel these I. I and I cancel. So what is remain? R equal to R1 plus R2 plus R3. So here the resistors are connected in series. So this is RS. So what is RS? Resistors are connected in series. So what is the equations for series connection? R is equal to R1 plus R2 plus R3, which means total resistance. So this is the total resistance. Total resistance is equal to the sum of individual resistance. So what is the explanation of this? Total resistance, if resistors are connected in series, the total resistance is equal to the sum of individual resistance. Total resistance is equal to the sum of individual resistance and it is greater than, so this sum is always greater than the individual difference. For example, if R1 equal to 5 and the total resistance is 10, which is more total resistance, right? So total resistance is always greater than the individual resistance. So series connection R is equal to R1 plus R2 plus R3, which means Total or resultant. Total or resultant, same meaning. So the resultant resistance or the total resistance is the sum of individual resistance, and it is greater than the individual resistance. Okay, so here you can see R1, R2 and R3 connected in series. V1 is the potential difference across the resistor R1. V2 is the potential difference across the resistor R2. And V3 is the potential difference across the resistor R3. It is observed from the experiment that V equal to V1 plus V2 plus V3. And I told you I is same for all the resistors, so you have to use only I. You don't want to use I1, I2 and I3 because I is same. So V equal to V1 plus V2 plus V3. Next, use the Ohm's law equation. V equal to IR, V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. Substitute here. V equal to IR, V1, IR1, V2, IR2, V3, IR3. So here you can see I is common everywhere. So take it out. So IR equal to I into R1 plus R2 plus R3. Cancel this I. R is equal to R1 plus R2 plus R3, which means the net or the resultant resistance is the sum of individual resistances, and it is always greater than the individual resistance. That is R is equal to R1 plus R2 plus R3. Okay. If n resistors of each value are connected in series. If I told you many resistors we can connect in series, right? So if n resistors of value are connected in series, R equal to R plus R etc. N means what? What is the meaning of this? This means n resistors are connected in series. If n resistors of value R are connected in series, so their equivalent resistance R is equal to NR. R is equal to NR, which means if three resistors like R plus R connected in series, if three resistors of value R is connected in series, the total resistance equal to 3R. Here you can see 1 R plus 2R plus 3R. So this is equal to 3R. So if n resistors are connected in series, R is equal to NR. If 3 resistors are connected in series, 3R. If 4 resistors are connected in series, 4R. If 5 resistors are connected in series, 5R. So this is very important. Okay. So if n resistors of value R is connected in series, the total resistance R is equal to NR, which means if 5 resistors are connected in series, 5R. If 3 resistors are connected in series, 3R. Okay. So if n resistors are connected in series, the total resistance R is equal to NR. Okay. Resistors are connected in parallel. See, R1, R2 and R3 are the resistors connected in parallel. Okay, and I1 is the current flows through the resistor R1, and I2 is the current flows through the resistor R2, and I3 is the current flows through the resistor R3, and V is the potential difference. Right. So R1 is R1, R2 and R3 are the resistors connected in parallel. I1 the current through the resistor R1, and I2 is the current through R2, and I3 through the R3, and V is same in parallel connection. In parallel connection, what is same? V same and I is different, right? So R1, R2 and R3 are the resistors connected in parallel because their one end is connected to one point and another end is connected to another point, so that the potential difference across each resistor is same. Okay, if the potential difference is same, which indirectly tells you that I is different. So I1 is the current through the resistor R1, and I2 is the current through the resistor R2, and I3 is the current through the resistor R3. Okay, and V is same for all the resistors, so only V. Okay, and it is proved from the experiment that I equal to I1 plus I2 plus I3. I equal to I1 plus I2 plus I3. Okay, then you have to find the Ohm's law equation for I. What is the Ohm's law equation for I? I equal to V by R. I equal to V by R. Then what about I1? I1 equal to V1 by R1. Is it correct? We have to use V1? No. Why? Because V is same for all the resistors. So I1 equal to VR1 and I2 equal to V by R2 and I3 equal to V by R3. I equal to V by R, I1 equal to V by R1, I2 equal to V by R2 and I3 equal to V by R3. Then substitute I V by R equal to I1 V by R1, I2 V by R2 and I3 V by R3. I3 V by R3. Then as usual V is common here, right? So take it out. You have to take V out. So V by R equal to V into 1 by R1. If V is taking out, so only what remains? 1. 1 into V. So 1 by R1 plus 1 by R2 plus 1 by R3. V by R equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Cancel V. So what do you get? 1 by R. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here the resistors are connected in parallel. So 1 by Rp. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for the parallel connection. If three resistors like R1, R2 and R3 connected in parallel, you will get the total resistance 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the total resistance is equal to the sum of reciprocals of individual resistance. Sum of reciprocals of individual resistance. Why sum of reciprocals? See R1. What is the reciprocal of R1? 1 by R1. So what is the reciprocal of? See, suppose R1. If anybody told you to write the reciprocal of R1, 1 by R1. So what is the reciprocal of R1? 1 by R1. So 1 by Rp equal to reciprocals of these resistors, right? 1 by R1 plus 1 by R2 plus 1 by R3. So the reciprocal of R1, 1 by R1. Reciprocal of R2, 1 by R2. Reciprocal of R3, 1 by R3. So you can say that the total resistance is the sum of reciprocals of individual resistance. That is 1 by R1 plus 1 by R2 plus 1 by R3. Reciprocals of individual resistance. Okay, so total resistance is the reciprocals of individual resistances. That is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So R1 and R2 and R3 are the resistors connected in parallel, and I1 is the current through R1, I2 is the current through R2 and I3 is the current through R3, and V is common for all the resistors, and it is proved that I equal to I1 plus I2 plus I3. Then you have to make find the Ohm's law equation like I equal to V by R. Then write the Ohm's law equation for I1, I2 and I3. I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. Why? I equal to V by R. So for R1, V by R1, V by R2 and V by R3. Then substitute here I equal to I1 plus I2 plus I3. So I means V by R. V by R equal to V by R1 plus V by R2 plus V by R3. Take the V out. So V into 1 by R1 plus 1 by R2 plus 1 by R3. Cancel V. That is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. It means total resistance is the sum of reciprocals of individual resistance, which means reciprocal of R1, 1 by R1, reciprocal of R2, 1 by R2, and reciprocal of R3, 1 by R3. Their sum is 1 by R1 plus 1 by R2 plus 1 by R3, that is equal to 1 by Rp. So total resistance or the resultant resistance is the sum of reciprocals of individual resistance. Okay, so that is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n resistors of value R is connected in parallel, which means 1 by Rp equal to 1 by R plus 1 by R plus 1 by R etc. n. So here how many resistors are connected? N resistors. So if n resistors of value R is connected in parallel, then the total resistance equal to n by R. So 1 by Rp equal to n by R. If n resistors are connected in parallel, then the total resistance 1 by Rp equal to n by R. See, 1 by Rp equal to n by R. So we have to find the Rp, no? We have to find the value Rp, not 1 by Rp. So how to find Rp? If 1 by Rp equal to n by R, Rp equal to R by n. 1 by Rp equal to n by R. So Rp reciprocal. Take the reciprocal. So reciprocal of 1 by Rp, Rp. And reciprocal of n by R, R by n. So 1 by Rp, take it down. You know reciprocal. 1 by Rp, the reciprocal of 1 by Rp, Rp. And the reciprocal of n by R, R by n. So Rp equal to R by n. So if you want to find the Rp, here we proved that 1 by Rp equal to n by R. So we have to find Rp. So how to find Rp? Take the reciprocal. Rp equal to the reciprocal of n by R, R by n. For example, if three resistors of R connected like 1 by Rp equal to 1 by R plus 1 by R plus 1 by R. So how many resistors? 3 resistors. So the total resistance equal to 1 plus 1, 2, 2 plus 1, 3. 3 by R. So the resistance equal to 3 by R. Which means 1 by Rp equal to 3 by R. Rp equal to R by 3. Got it? If 3 resistors are connected in parallel, the total resistance equal to 3 by R. 1 plus 1, 2, 2 plus 1, 3. That is n by R. Okay. So 1 by Rp equal to 1 plus 1, 2, 2 plus 1, 3. Then R. So 3 by R. So 1 by R3 equal to 3 by R. So if you want to find the Rp, take it reciprocal. So R by 3. Okay. So if n resistors are connected in parallel, then total resistance 1 by Rp equal to n by R and Rp equal to R by n. Okay. As you know, we can connect the resistors in two ways, like series connection and parallel connection. Right. So now we are going to discuss about what are the disadvantages of series connection over parallel. Okay. Right now we discussed about the series connection and parallel connection, and we derived the equation also. And now we have to find out what are the disadvantages for the series connection over parallel connection. So which is the right connection, which is the good connection. Okay, so the first disadvantage of series connection over parallel connection is that it is impracticable to connect an electric bulb and an electric heater in series circuit because they require different amount of current. The bulb and the heater consumes or requires different amount of current, but the series connection, in the series connection, the same current flows through the each resistors. That we discussed that in series connection, or I is same for all the resistors in series connection, which means the gadgets in the series connection should use same current for their working, right? But if we connect a bulb and the electric heater in the series, they require different amount of current. It is not practicable to connect them. Why? Because both the bulb and the heater consumes or requires different amount of current. So the first disadvantage of series connection is that it is impracticable to connect different gadgets in the series circuits because they require different amount of current. Like bulb and heater cannot connect in the series connection because both the gadgets requires different amount of current. So the first disadvantage of Series connection or the parallel connection is that it is impracticable or it is inconvenient to connect different gadgets in series connection because they requires or they need different amount of current. Okay, and the second one, if one of the component fails, if there is any problem in one component, the entire circuit breaks and none of the components works. Like our fairy lights, our decorative fairy lights, you can see there more bulbs are connected in series connection, and also you may see that the electrician is spending lot of time to locate the troubles because it is very difficult to find out the troubles, because if there is any small problem in any of the component in series connection, it affects the entire circuits. So the entire circuit breaks and none of the components breaks. So that is a second drawback. If one of the component fails or if there is any small problem for one component, the circuit breaks and none of the component works. Okay, on the other hand, parallel connection or the parallel circuits divides the current through the electrical gadgets. So it is convenient to connect different gadgets in parallel connection, or different gadgets can connect in parallel because parallel connection divides the current through the different gadgets, because current is different in parallel connection, right? So we can connect. So which is the correct method of connection? Parallel connection. Why? Because parallel connection divide the current to electrical gadgets. So the good way or the correct way of connection is parallel connection. And what are the disadvantages we discussed? First one, if it is impracticable to connect different gadgets in the series connection because they requires different current, like electric bulb and electric heater cannot connect in the series because they require different current. And the second one, if one of the component fails, circuit breaks and none of the component works. Like fairy lights, if there is any problem in any of the bulb, it affects the entire circuit. And the parallel circuit divides the current through the electrical gadgets. So the convenient way of the connecting the gadgets is in parallel connection, because parallel connection divide the current through the electrical gadgets. Okay, so that's all about our today's class. See, whatever point we discussed in our today's class is very important, and all the points are exam oriented point. So understand it well and watch the video carefully. We will meet you soon with another video. Until then, it's bye. Thank you for watching. Have a great day ahead.